Hi all, in this video we'll look at adding and subtracting rational expressions. Please try to work through these problems before you watch the video and then go through the video to make sure you're doing things correctly. As with 5.1, we're going to review a couple of the topics in this section that we saw in 5.0 of the text. Alright, in example 1 we're asked to simplify 12/35 plus 3/35. Noting that we have a common denominator, we can just add these together by first writing the denominator in the denominator the common one, and noting we can just take 12 plus 3, giving us 15/35. Now, with that, we need to be careful that we pay attention to the fact that we were asked to simplify this, and though we've now combined this into one fraction, that's not in lowest terms. We need to make sure that we get it there. Recognizing there's a 5 in common in each, we can write 15 is 5 times 3, and 35 is 5 times 7, and cancel out the 5s and be left with 3/7. Right. So that should be our final answer with that. And again, this is simplified as we have no common terms. The new rule we have with this is that A over B plus C over B should be, well, we've got the B in common, A plus C over B. Now here, B can't be 0. Whatever's in the denominator can't be 0. And this is, we're going to see a similar idea, basically the exact same idea. If I have A over B minus C over B, this should be A minus C, everything in C over B. And as with before, we want to be real careful about the B not being equal to 0. As we extend this to look at rational expressions where there are variables involved, we need to make sure we exclude anywhere where the denominator would be 0 from our final answer. Alright, let's look at example 2. Here we're asked to simplify 8/15 minus 7/10. Well, for that, we don't have a common denominator yet, so we need one. So let's take a second, and you may want to work through this yourself before watching the rest of this, but we need to find the least common denominator between 15 and 10. There's a few different methods for doing this. You can factor it out into prime factorization and go from there. Any road you take should lead you to the same correct answer, that the least common denominator between 15 and 10 is 30. So looking at 15, what I need to multiply 15 by to get to 30 is 2. So I want to multiply that first expression by 2 over 2, which is okay because that's just 1. I'm not changing this amount, I'm just rewriting it in a better form for what we're doing here. Going from 10 to 30, I would have to multiply 10 by 3, so I want to multiply that second expression by 3/3, which again is equivalent to 1, but will get me to what I want to have here. So this is going to give me, say that the original problem was equivalent to 16/30 minus 21/30, which is equivalent to 16 minus 21 over 30, or negative 5/30. And it'd be great if I could stop there, but again, we're going to notice we have a factor in common between the 5 and the 30. So I can rewrite this as 5 times a negative 1 over 5 times 6. The 5's cancel out, and I'll be left with a negative 1/6. Alright, so that's an idea we're going to be using later. Looking down at example 3, let me move this page down a little bit. I got 2/7 plus 4/15. 7 and 15 have no common factors, so the LCD will actually be 7 times 15, or 105. That means I'm going to need to multiply the first term by 15 over 15, the 2/7 rather, by the 15 over 15, and the 4/15 by 7 over 7. Now this process here is going to give me a common denominator of 7 times 15 of 105 in the denominator, and my numerator should be 15 times 2, 30, plus 7 times 4 is 28. Working this out, I will get 58/105. 58 divided by 105, and those do have no common factors. So this is my final answer, and it's simplified. So this is the review of 5.0. Now let's go on to example 4 and look at some new stuff for 5.2. In example 4, we're asked to add or subtract the following. If the domain is not given, find the domain. I'll point out here in this first example, we're told that x should not be equal to -5, and that is the domain. So we're given the domain here, and again, that comes by looking at where the denominator would be 0 and excluding that. So we can't have -5 because that would make the denominator 0. Alright, so since we have a common denominator, following with our rule from before, we can take this and just say this should be equal to, well, I got a common denominator among the two things. X plus 5 goes on the bottom. I can take that x squared minus 42 plus the quantity 7 minus 2x. And again, this is just fitting with that form. Like we have something of the form a over b plus c over b should be a plus c over b. Now you'll notice I put these terms, the x squared minus 42 and the 7 minus 2x, I put those in parentheses. For this particular problem, it's not going to matter. That is, with an addition problem, that's not going to affect the problem. We want to be more careful when we're dealing with a negative like we are, or a subtraction like we are on the next problem. Alright, continuing with this, we have x squared minus 2x, just rewriting it in terms of descending order. And I'll notice, well, we didn't really need those parentheses, so let's actually just get rid of them. Combining like terms on the numerator, I've got the negative 42 plus 7. Well, negative 42 plus 7, that should be a negative 35, I think. So that's x squared minus 2x minus 35 over x plus 5. Of course, we need to factor the numerator. Alright, and doing that, we should see that this is going to be x plus 5 times x minus 7 in the numerator, all over that x plus 5. And hopefully we're seeing here those x plus 5s are canceling. So we're left with a final result of this addition of two rational expressions as x plus 7, again with the domain of x does not equal -5. Alright, so that's my answer there. And it didn't say this here, but we certainly want to simplify. So let me maybe write that in with my instructions. Okay, B. Now here we're subtracting two rational expressions. And we first want to start off by finding the least common denominator if those denominators are not the same. Before we do this, let me put out a rule that we're going to need to know here. So let me do this in green. We need to know this rule. This is similar to a rule we saw before. But a minus b is equal to the negative of b minus a. Alright, and some of you may recognize where I'm going with this. That x minus 1 looks an awful lot like 1 minus x. Not quite the same though. And this rule will tell us how to deal with that. As we go forward, we're going to need to recognize something else. A over a negative b is equal to a negative a over b. This is a rule from a while back, which is really the same as a negative of a over b. All of those, let's make sure I did that line right, of the whole expression. I can rewrite things in that way. So we have a couple, call this rules here, and we're going to need to know those for this problem. Okay, making use of this first rule, the a minus b equals the negative of b minus a. That allows us to rewrite that second expression. So that 9x plus 1 over x minus 1, we're going to leave that alone. The 6x plus 2 over 1 minus x, that's the same as 6x plus 2 over the negative of x minus 1. Okay, again, 1 minus x is equal to the negative of 1 minus x. To see this, feel free on your paper to distribute the negative here in this part that I've just underlined in red and regroup it. Just see that those are the same. But those are indeed the same, and that's something we need to recognize in this problem. Making use of this bottom part down here, this negative a over b, this term right here, I can just bring that negative out to the front. So that rewrites this original problem as 9x plus 1 over x minus 1 to be a minus the negative of 6x plus 2 divided by x minus 1. So this negative I have right here, I can bring it out to the outside. You should also notice I'm subtracting negative. That's the same as adding a positive. So I'm running out of room here, so let's move this up here. So I've got this as 9x plus 1 over x minus 2 plus 6x plus 2 over x minus 1. That was lots of setup to get to this, But now I've got something pretty easy to deal with. So continuing on from this top line, I've got a common denominator already. The x minus 1 is my common denominator. I just need to deal with the 9x plus 1 plus 6x plus 2. You know, my like terms are the 9x and the 6x. That's 15x. Plus, I got a 1 plus 2 is 3 over x minus 1. I'm almost there. I got a 3 in common among the terms in the numerator, so this is 3 times 5x plus 1 over x minus 1. Nothing to factor out there. My domain's written down already as that x minus x does not equal 1. This is my final answer. Let's go on to step C. Again, we're going to continue with the adding or subtracting and finding the domain and simplifying. In example 3, we see that we don't have a common denominator between these two expressions. Let's find that. So the LCD here, let's do that in black. The LCD should be, well, take a minute and try that yourself, but you should get 30x squared as my LCD. So what this first term needs to be multiplied by is 5, and the second term should be, the denominator needs a 5 to be multiplied by that to get the LCD, and the second term needs a 2x. So I'm going to multiply the first fraction by 5 over 5. It's always okay to multiply by 1, times the 5 over 6x squared, plus, well, I'm going to take 2x over 2x times 4 over 15x. And simplifying each of those, we'll get 25 over 30x squared plus 8x over 30x squared. Well, now we have a common denominator. So that common denominator is 30x squared. Let's make that a squared for real. So that should be 25 plus 8x in the numerator over 30x squared. And there's nothing to factor out in the numerator. I have no common terms to factor out. We're done. So sometimes that'll work out pretty easily. Need to deal with the domain here. Alright. I'm going to look at the most factored form of the denominator, and the 30x squared is pretty well it. So that's what I need to have not equal 0. Dividing both sides by 30, we'll get x squared should not equal 0. Or, that's an arrow, taking the square root of both sides. Square root of 0 is 0, or plus or minus 0. Yeah, I think that's always 0. So the domain should be x cannot equal 0 here. Looking at D. Alright, now we have a term in the left fraction, x minus 4. We have a term in the right fraction, x plus 2. Our least common denominator, those terms have nothing in common. No greatest common factor between them. There's no factor at all other than 1. So the least common denominator actually will be x minus 4 times x plus 2. So the first fraction, first rational expression, needs to be multiplied by x plus 2 over x plus 2 to give us that common factor, least common denominator. The second rational expression needs to be multiplied by x minus 4 over x minus 4 for this to work out correctly, which is going to lead us to, so this equals this, and let's make a little more room. Continuing this down, well, we have x plus 2 times x from our first fraction. We have plus x minus 4 times x minus 1 from our second fraction. And this is all over our common denominator of x minus 4 times x plus 2. Alright, so we need to work out the numerator and see what that gives us, and go from there. So let's distribute the x from this for this first term. That'll give us x squared plus 2x. With the second term, I'll FOIL that and get x squared minus x minus 4x plus 4. And just keep on bringing down that denominator, x minus 4 times x plus 2. Continuing working with the numerator there, give myself some more space. I'm going to look for common factors in the numerator. I have an x squared along with an x squared, so that's going to be 2x squared. I have a 2x, negative x, and a negative 4x. So 2x minus x is x, minus 4x is a negative 3x, and then the only constant term I have here is the 4, I'll just do that in black, plus 4, all over x minus 4 times x plus 2. The denominator always just coming along for the ride. Right, we're just keeping it there. Now I want to look to try to factor that numerator, and I'm going to kind of go through this discussion with you. So let's look at that. Again, one of the methods we talked about in class was by finding the product of the first and the last terms. The product here of 2 and 4 is 8. So we're looking in for two numbers whose product is 8, and the middle term here is a negative 3. That's what the sum of those terms would have to be. Okay. Now again, we're looking for two integers who multiply together to give you 8 and who add up to give you a negative 3. Well, if they're going to add up to be a negative 3, they're going to have to be, at least one of them is negative, and if their product is 8, that means their signs are the same. They're either both positive or both negative. For these two things to be true at the same time, they would have to both be negative. So I want a product of 8. Let's start at negative 1. Negative 1 times negative 8 is 8. The sum of negative 1 and negative 8 is negative 9, so that did not work. That's a wrong sum. Continuing on, after 1 comes 2, so negative 2 times a negative 4 gives me a product of 8. That sum is negative 6. That didn't work. If I continue on, 3 doesn't go into 8, 4 does, negative 4. I'm back to a negative 2. I'm just repeating my list. I'm done with my list. So there were no set of integers whose product is 8 and whose sum is negative 3. So that means this is actually going to tell me that this expression up here, that's prime. If that's prime, I can't factor it. If I can't factor it, I can't cancel anything out, and it's simplified. So, checking that, I see this was my final answer. Alright, so we still have the domain question. Looking at the domain, we're really looking at what's going on in the denominator, and going back to the original denominator, which is really equivalent to going back to the LCD. We're looking for what would make either of those 0, and we're trying to exclude that. So we want to say x minus 4 can't be 0. I also want x plus 2 to not be 0. Adding 4 to both sides on the first one, we're going to see that x should not be 4. Subtracting 2 from both sides on the second, we'll see that x should not be negative 2. So the domain should be the set of all x so that x is not 4 or negative 2. On to question E. To start with on E, we want to find the least common denominator. But really to help us with that, let's first factor the denominators in each of the two rational expressions, in each of the two fractions. For this first expression, the denominator is going to factor to a plus 3 times a plus 2. In the second rational expression, the denominator has a 3a in common, so it should be 3a times a plus 3. Alright, so we should see from that our least common denominator will be 3a times a plus 3 times a plus 2. Alright, and from that, I'm going to get a little more space going here. I need to multiply the first expression by 3a over 3a. And the second expression I need to multiply by a plus 2 over a plus 2. So continuing on with this. So multiplying that first expression by 3a over 3a, the numerator is going to be distributing the 3a times the entire a minus 2 will be 3a squared minus 6a. Again, I'm going to have that over the 3a times a plus 3 times a plus 2 minus the product of 2a minus 3 times a plus 2. Alright, so let's do that. I'm going to put this whole thing, the product of this part here, right down here inside of these blue parentheses. So I'm going to FOIL 2a minus 3 times a plus 2. That'll give me 2a squared plus 4a minus 3a minus 6. Now, you see these blue parentheses here? They have a minus sign in front of them. I need to be very careful about distributing the negative here. Alright, so with doing that, I'm going to have this is 3a squared minus 6a. It's just a line between these two. Minus 2a squared minus 4a plus 3a plus 6. If you combine those terms together, that's great. If not, that's okay. Got my denominator here. Just keeps coming along for the ride. This should equal, well, I got 3a squared minus 6a minus 2a squared. Now let's look for some like terms. Alright, so I got a 3a squared and a minus 2a squared. Those combined together to give me a squared. Got a negative 6a minus 4a, that's a negative 10a, plus 3a is negative 7a. And then it looks like I've got a plus 6 left, and I'll just do that in black. Alright. So it's a squared minus 7a over plus 6 all over 3a times a plus 3 times a plus 2. Right, still need to factor the numerator if I can. Working this out yourself, you should get a minus 6 times a minus 1 all over 3a times a plus 3 times a plus 2. Now looking at this, I've got the top is factored into linear terms, the bottom is factored into linear terms. There are no common terms. Nothing's going to cancel. Nothing's going to simplify. This is my final answer for that. Still got to do the domain. The domain, again, we can base this on the LCD. Let's do that. I have 3 terms in that. I need to determine where each of those 3 terms isn't equal to 0. Dividing the first one by 3, I'll get that a can't be 0. Taking that second one, a plus 3 shouldn't be 0. Subtracting 3 from both sides, I'll get that a cannot equal a negative 3. And the last one, a plus 2 shouldn't equal 0. Subtracting 2 from both sides, we'll see that a should not equal a negative 2. So our domain is a set of all real numbers in which a doesn't equal 0, negative 2, or negative 3. On to F. Alright, so let me put a brown line here so I can separate out E and F. Here? Okay. Now, as with the last one, I need to factor the denominators of each of these terms first to help me find the least common denominator. So I'm going to do this, and to give myself a little more space, I'm going to write kind of small. So this first one should be x plus 2 over, this is going to factor to be x plus 3 times x minus 2 minus plus the second term is x minus 1 over, well, x squared minus 4 is a difference of 2 squares. That should be x plus 2 times x minus 2. Alright, let me make that a little clearer here. So let me erase a little bit of that. Move my brown line just a little bit. I'll move my brown line with a pen just a little bit. Really, I can do this. Now let's make my black x plus 2 times x minus 2. So we see we have an x minus 2 in common. I also need an x plus 3 and an x plus 2. So my LCD should be x plus 3 times x minus 2 times x plus 2. That means I need to multiply this first fraction by x plus 2 and the second one by x plus 3. So doing that, I'm going to have x plus 2 over x plus 2 times x plus 2 over x plus 3 times x minus 2 plus x plus 3 over x plus 3 times x minus 1 over x plus 2 times x minus 2. Alright, so this will be involving in the numerator quite a bit of multiplying out things and then combining like terms, and that's what the rest of this is going to look like. We're going to be multiplying out what we have in the numerators, adding together, combining like terms, and then simplifying the results of that. So knowing what we're going to get into can help us out in doing that. But let's keep that common denominator together. It's always going to be x plus 2 times x plus 3 times x minus 2 until maybe we'll get to simplify some of that at the end. Alright, so distributing like terms in the first product here, I have x plus 2. Let's underline what I'm looking at. I have x plus 2 times x plus 2. Foiling that, I should get x squared plus 2x plus 2x plus 4. Some of you may have recognized that as a common, as one of the common factors or products we're going to need to know. The special products, it's a different, or it's the same quantity times itself. It's a perfect square. So you might have seen that as a 4x in the middle. That's fine. 2x plus 2x is 4x. Coming over here, the x plus 3 times x minus 1. Foiling that will give me x squared minus x plus 3x minus 3. Alright, and going through and combining like terms. Alright, I have an x squared and an x squared. That should be 2x squared. Alright, I got 2x plus 2x is 4x, minus x is 3x, plus 3x is plus 6x. I got a plus 4 and a minus 3, that's plus 1. Alright, and my denominator here is x plus 2 times x plus 3 times x minus 2. Alright, trying to factor this numerator. Again, I'm going to look for values in which I have a product of 2 and a sum of 6. I'm looking for two numbers whose product is 2 and sum is 6. Since the product is positive, the numbers are going to have the same sign. Since the sum is positive, they'll have to both be positive. The only numbers I can think of that are integers and give me a product of 2 is 1 and 2. Their sum is not 6. So I can't do this. This is prime. That the numerator is prime over their integers. And I am done with that part. Gotta do the domain. Domain. Alright, in my favorite little purple pink there. My domain again is based on the LCD. So I'm finding out where each of those three terms can't be 0. X plus 3 can't equal 0. X minus 2 can't equal 0. X plus 2 can't equal 0. And work this out yourself, but you should see that this is where x is not equal to negative 3, 2, or negative 2. That's my domain. I've got my simplified form here, and that's F. Let's look at G. On G, I have three terms here, but I'm really going to want to start by first factoring each of the denominators. The a minus 2 and a plus 2 are already factored. Let's factor that third one then. So this should look like 5 over a plus 2 plus 5. I'm sorry, that should have been 5 over a minus 2. Not intentionally rewording this. A plus 2 minus 6 over a squared minus 4. That's a difference of two squares. That is going to factor to a plus 2 times a minus 2. So that's going to tell me my least common denominator. And I'm kind of doing this on the same page. I would do this in my notebook on normal paper off to the side. But my least common denominator is x plus 2. I'm sorry, a plus 2. Just make that an a times a minus 2. That means I need to multiply the first term by a plus 2, the second term by a minus 2. Let's try that again. The first term by a plus 2 over a plus 2, the second term by a minus 2 over a minus 2, and the third term by absolutely nothing. So it's already good. So again, I need to take that first term, just coming down from there, multiply it by a plus 2 over a plus 2 times 5 over a minus 2 plus a minus 2 over a minus 2 times 5 over a plus 2 minus, that one just gets to come along for the ride. The 6 over a plus 2 times a minus 2. Alright, once I do that, I'm going to have that common denominator among all three, and I'm going to be able to just combine all those terms together. So I'm going to have this common denominator of a plus 2 times a minus 2 all along toward the bottom there. Distributing from this first term, I'm going to have 5a plus 10. And again, that's coming from here. Let's do that in a different color. From here, I'll get that coming here. And the 6, I'm going to have that be last in a second. the 5 times a minus 2 should be plus 5a minus 10. And I've got a minus 6. Again, be real careful about this minus sign. It's going to come along here. Combining like terms in the numerator, 5a plus 5a is 10a. Plus 10 minus 10, that's 0, minus 6, all over the common denominator of a plus 2 times a minus 2. I have a common term of 2 in the numerator times 5a minus 3 all over a plus 2 times a minus 2. Don't see anything in common. That's as simple as this can get. So let's look at our domain. Again, looking at the least common denominator, should see that a plus 2 can't be 0 and a minus 2 can't be 0. So a should not be in negative 2 or 2 instead of all a. So that a is not negative 2 or 2 should be my domain. And that's the notes for 5.2.